let's look at this question, part E. This is still past paper from exam 2007. Should be question 3E. Now we want to calculate this. Determine the threshold frequency for a metal that releases an electron with maximum kinetic energy of this much when light of wavelength this much shines on it. So let's try to do this one. Let's use the color. This one, this color. Okay, all right. Determine the threshold frequency. We know that the threshold frequency is going to be F0, and it is phi, work function of a metal, over h, Planck's constant. We are given Ek here, 3.94 times 10 to the power of -20. And we know that Ek is going to be E photon minus phi. So from this equation, we should be able to calculate phi. Phi is going to be equal to E photon minus Ek of electrons. Now E photon can also be represented by H times F minus Ek. We are not given the frequency of the light, but we are given the wavelength of the light. We know that we have lambda wavelength times frequency f is equal to c, speed of light. Now we can rewrite this into f is going to be equal to c over lambda. So we want to plug this f into here. So we will have phi is going to be equal to hc over lambda minus ek. And since we have f0 is phi over h, we can rewrite it as hc lambda minus ek over h. And we can cancel out h for this one. So we have c over lambda, and here is going to be minus ek over h. So it is going to be 3 times 10 to the power of 8. So remember, c is a constant. Lambda is your 4.01 times 10 to the power of -7, minus ek is given 3.94 times over h, Planck's constant. Now let's do it on our calculator. We have 3 times 10 to the power of 8 over 4.01 times 10 to the power of -7 minus, what is the number? 3.94. 3.94 times 10 to the power of -20 over 6.63 times 10 to the power of, we have 6.89 times. It's going to be equal to 6.89 times 10 to the power of 14 hertz. Now this frequency is your threshold frequency. Okay.